The three stages of production, we have the increasing the tens that starts from 0 here. It goes up until the point where it reaches average product of labor here at the maximum of the AP L. And then decreasing the tens starts from the maximum of the AP until it reaches 0 here, until marginal product of labor reaches 0. So that's the second stage. And the third stage is negative returns that starts from the 0 point until the negative side. So that's the negative side. And I'd mentioned to say the first stage is regarded to be irrational, because a firm is not utilizing all resources that it has. It is not utilizing all resources that it has. It is using less of the resources. And then the second one, the diminishing marginal returns, is considered to be rational, because a firm is going to be using all the resources that it has, even though it is producing at a decreasing rate, but total product is still increasing. Then the last one, negative returns, is going to be considered irrational, because you find that a firm is now making it has now reached negative parts. So this total product will start decreasing if it continues producing even after the marginal product reaches 0. Okay, are we okay on that? Yes, go ahead. Go ahead if you have something to say. Kayaka screening.
Because I wanted to ask,
Yes, go ahead.
why is it that this is the diagram that we use for return to scale, the one that you were given in the note for increasing constant and decreasing?
um what do you mean? Are you comparing economies of scale or with increasing the tens, or what?
I'm lost. So
You're lost. How are you lost? Ask your question.
my question is that return to scale, why do you use the diagram that we were given, the one that I gave us in the notes it, for increasing constant and then decreasing?
Oh, you mean those graphs that we were drawing, where we are increasing is like that, constant something, some those my graphs like that? Or I don't know if I'm answering the wrong question, or are you
Yes,
talking about? Oh, okay.
yes, because of that.
No, so these graphs are only going to be to help you to explain when we're talking about returns to scale. So when you're told to say explain returns to scale, and then you graph each return to scale on a graph, that's when you use those graphs. Here, the
Oh,
graph that
okay.
yeah, the graph that I drew was not talking about the tends to scale or anything like that. We here we're talking about stages of production. We're talking about stages of production. A firm will first increase exponentially, then it will stop increasing exponentially, and it will start uh, increasing at a decreasing rate. So that's what we meant. So we don't use those there. Now on the
Okay, okay.
okay, so now on the okay, for like for example, question E was saying discuss the tends to scale with the aid of the. So if you've seen this graph, we're going to do the exact thing that we are just from asking. So we draw the graph, we show to say here it is constant returns. If we have another thing, it is increasing returns. If we have something like that, we have um decreasing returns to scale, isn't it? So from this part to the other part, we have decreasing returns. If we have just this part, we have increasing returns. If we have this and that, we have increasing constant returns. So what I'm saying is this to those that are lost. In returns to scale tries to explain how the quantity that is being supplied by the firm is changes when we double the inputs that are being used in production. So we have the first one is increasing returns to scale. When we double the inputs by maybe let's say 10%, and then the output come out maybe let's say 20, by 20%. Okay, by 20%. How so you find that there's an increase from 10% to 20%. Yeah. And then constant returns are going to be built, whereby if we increase the quantity, I mean the inputs by 10, then the output comes out by 10%. This exact thing that we put in, you find that this is constant because we put 10% of the inputs, then the output came out as 10%. So we consider this to be constant. And then decreasing will be, we double 10%, then what comes out is 5%. So it means that now this is um diminishing, I mean, yeah, decreasing returns to scale, because here it will be increasing at a decreasing rate, while the first increasing one will be increasing at an increasing rate. Okay. Yes, there's someone with a question. Go ahead if you have a question. I can't see the screen for people. I don't know what happened, but if you have a question, go ahead.
It's Faith. I think she forgot to put her hand down.
Okay. Okay, so that is that about those. You can even draw to graph mamenena kambila paso. Now, on F, guys, what time is it? Ngai wareko tigone 24 hours. What time is it? I can't see the time.
44.
1944.
What time should we end? If you have questions, start forming them, because
1944.
what time should we end? Ngati mwina questions, start forming those questions, because we'll be finishing anytime soon. Yes, go ahead.
Yeah, I have a question on the second part of production. So, in terms of rationality, is it irrational or rational?
It is rational. Firms produce on the second part, where the stage is diminishing marginal, it is facing diminishing marginal returns, because there the firm is using all the resources that it has, and production will be increasing but at a decreasing rate. That is what they consider rational, not irrational. Irrational is considered at the increasing rate and at the negative returns.
Right. Thanks.
Then question A for saying graph isoquants on a clearly labeled diagram and discuss its properties. So isoquants okay. So isoquants, um I can try to run through until 21 hours if you're okay with it, or if you want 2030, it's okay, that's up to you.
21 shares was.
Yeah, I'm exhausted, but it seems like we still have a lot of things to do, and I know that we are all facing issues, so let's try to do this. We can still push. Okay, so where is it? Okay, question F was saying we graph isoquants on the clearly labeled graph and discuss its properties. So now, graphing these isoquants, we have to understand, to say what is an isoquant, you have to understand the definition for an isoquant. Okay guys, if we're going to speed up, let me just speed up. Okay, if you have a question, you ask fast. If you have something to contribute, you contribute fast, because of time. It seems like we're consuming too much time when we start interacting, so I'll be fast and I'll make sure that at least we cover up at least 2 tutorials. So make sure that you ask a question where you feel like asking. Nambokamba fast manjai. Okay, so what is an isoquant? An isoquant is simply a curve that tries to show, an isoquant is a curve that shows possible combinations of inputs that are put in production, and they give out the same level of outputs. Okay, so that is what? An isoquant. So the properties of an isoquant is downward sloping. So an isoquant looks like that. you can draw curves like that, and you show to say these are isoquants. An isoquant is downward sloping, which shows the marginal rate of technical substitution. Okay, it is simply a rate at which a firm is going to be substituting one input for the other.
Yeah.
Okay, so the other property is that an isoquant or isoquants are do not cross, because if they were crossing, it will mean that one input is going to be producing this two different level of outputs. So an isoquant these isoquants do not cross. The third property can also be an isoquants that are further away from the origin are considered to be more productive than the other one, because this one is going to use more inputs, and it is going to have more it will have more level of outputs that are going to be coming out from there. Okay, so the properties of isoquants you can check in the notes, you go through those, or you can research more on it. There are more, but those are the properties, and that is how you explain the properties without wasting time. Question G is saying draw an isocost map and discuss the properties of an isocost. So an isocost map, or just an isocost. So an isocost is simply a curve that shows various combinations of inputs that cost the same amount. Okay, so it is going to show the different combinations of inputs that are used in production that cost the same level of what what's this inputs. Of course, I know it's a line, you can say curve or line or something like that, but yeah, it is called that. Okay, now the properties are that it is downward sloping, which shows the substitution effect that is there. You can substitute one input for the other input, so it is like that. Downward sloping, you can as well try to research more on the properties of isoquants if you wish to understand them. But yeah, then H is saying discuss the long run equilibrium output discuss the long run equilibrium output decision of a firm. So what um, this is saying or asking us to do is, in the long run, the firm will try to maximize the output. The equilibrium output is going to be at the point where the firms are going to be producing at the point where marginal. Okay, so we don't include this here. We can include that at the last part, but we can bring about the point of equimarginal principle, where we say a firm is a firm is going to choose points where inputs that are at the point where the isoquant is tangent with the isocost line here at this point. Okay, so if they choose at this point, it means that this firm is satisfying the condition that says marginal revenue is equals to marginal cost, or price is equals to marginal cost. So these conditions can be satisfied at this point. Okay, I think we are done on that. Do I have any question, any contribution? We move on to another tutorial. We just do the last tutorial that I think is important for now. Okay, let me cut this video.